Let's graph a rational function f of x equals x minus 1 over x squared minus 4. So what you really should do first is see if this can be written in lowest terms, see if there's anything you can reduce. Let's factor the x squared minus 4. X minus 1 cannot be factored any further, but x squared minus 4 can be factored into x minus 2 and x plus 2, as it is a difference of two squares. So we can clearly see that we cannot reduce anything, so that is definitely in lowest terms. Now we can also find the domain. So what I call the restricted value is a number that makes the denominator equal to 0, in this case the numbers. We said each factor equal to 0, and we get x equals positive 2, and here we have x equals negative 2. So this is my restricted value, and to write out the domain, we just make a number line down here. We have negative 2 over here, and let's say 2 is over here. So negative 2 and 2 are both not good numbers, because that would make the denominator equal to 0, and that makes it undefined. So the domain, everything on the left hand side, negative infinity to negative 2, parentheses. Parentheses means negative 2 is not included. Everything in between negative 2 and 2 works, and also from 2 to infinity. So this is our domain. Now we got to find some points, and let's start with the Y-intercept. To find the Y-intercept, we said x equal to 0. Let's hope I can put it all in here. So if x is 0, f of 0 is 0 minus 1 over 0 squared minus 4. All we have left is negative 1 over negative 4. The Y-intercept is 0, 1/4. So we have that point. Now to find the X-intercept, we set the numerator equal to 0, X-intercept. So x minus 1 is equal to 0. That gives us an x equals 1. So we have a 0 here, that would be at 1, 0. Now the vertical and horizontal asymptotes, I call them the VA and the HA. The vertical asymptotes, we basically already have determined them, because we set the denominator equal to 0 and we got the restricted values. So we have one vertical asymptote that's at negative 2 and one that's at positive 2. Now right away I'm going to make dashed lines. X equals negative 2 and at x equals positive 2. These are our asymptotes that we cannot cross or touch. Now the horizontal asymptote, we need to look at the degrees of the numerator and the denominator, because the degree of the numerator, which in this case is 1, is less than the degree of the denominator, which here is 2. That means the horizontal asymptote in this case is y equal to 0. So y equal to 0 is really the same as the x-axis. Y equals 0 is the horizontal asymptote. Okay, now we need to find some other points. So, and basically you have to choose points and plug them into the original blue function here, and you want to look at where you have your restricted values. So you want to choose a point that's to the left of negative 2. So let me say negative 3. Then I also in between -2 and 2, I'm going to pick 1, because I already have 0, that's my y-intercept. And I'm going to pick 3 on the right hand side, and let's see what happens here. So we need to plug in our numbers in the original problem. So let's see if I have enough room. F of -3 is -3 minus 1 over -3 squared is 9. 9 minus 4 is 5. Oh, let me write down. -3 squared minus 4. So we get -3 minus 1 is -4 over 9 minus 4 is 5. So we have 4/5. If I want to negative, that is, if I want to change it into decimal, would be easier to graph. My point would be -3 comma -0.8. 4/5 is 0.8. Okay, and the other point that I picked was 1. F of 1, let me write it over here. So let me plug it in here. F of, actually, I meant to say f of 1. I already have that. F of 1 is 0, so I'm going to make that -1. Sorry about that. F of -1 -1 minus 1 is -2, and -1 squared is +1. +1 minus 4 is -3. So my point here would be -1 comma negative divided by negative is a +2/3. And then I wanted to plug in 3, so f of 3 is 3 minus 1 is 2, and 9 minus 4 is 5. So that gives me 2/5, and if I change it into decimal, that would be 3 comma 0.4. Okay, so let me see if I can plot some points here and see what's going on. Let me use purple. We have our vertical asymptotes, we have our horizontal asymptote. 0, 1/4 is, let me make this actually a little thicker. 0, 1/4 was my y-intercept, and that is somewhere over here. Then I also had 1 comma 0, that is right there. And I had -1 2/3, -1 2/3. I plot this right there. And -3 was -0.8. -3 like here. And 3 was 0.04, so a little bit over here. So let's see what's going on. I can now kind of draw a smooth curve, so somehow this has to go like that. Now what happens on the other side? I either plot some more points like pick 4, but I know this has to come close to the asymptote like so, and this is really not a good drawing here, but you get the idea. It goes close to the asymptote, but it will never cross. And over here again, if I want to see, well, it can only really go this way here because of the horizontal and vertical asymptote, and it goes like so. So here you go. There is your rational function.